Hello and welcome to this video for the 2022 Level 3 integration paper for Level 3 Calculus. So for this paper, the answer schedule has not yet been released, but I will try my best to walk through the paper as is without the answer schedule, and I'll try to give an estimated grade briefing for each question. So keep a note that these estimated grades might not necessarily be accurate, and it's just a rough estimation of the grade based on past examination papers. So we'll just dive straight into it. So question number 1. Find the integral of 4 over x minus secant squared of x dx. So for these types of questions, I always give you the very simple integration questions at the start. So for these types of questions, you can just refer to your formula sheet on your level 3 calculus. Or you can just, after you do enough past papers, you will find that you mostly can memorize the basic integral. So for 4 over x, for integration, we're going to get 4 ln of x. So we're going to get 4 ln of x, and secant squared of x integrates the tangent of x, so this becomes negative of tan of x. And don't forget the constant of integration plus c. And this question, this should just be a simple achieve level question, very standard. Every year they will give you this type of question. So for question number B, graph of the function y equals to f of x below is symmetrical about the y-axis. The areas of the shaded region are given. So we do know that it is symmetrical. So if we see here, right here, this is a 4.4. So that means since it's symmetrical, the left-hand side is also 4.4. And likewise, this is also 1.2. So it wants us to find the integral from 3 to negative 3 of f of x dx. So for this question, we're just going to add up the areas, but keeping in mind that if the graph is below the x-axis, it's going to give us a negative integral, okay? So in this case, we're going to have 2 times of positive 4.4. Sorry. Let me try that again. That equals to 2 times of positive 4.4 minus 2 times of 1.2. And that should give us an answer of 6.4. And this should just be another standard achieve level question there. No, not too much hassle there. So question number C, we're going to find the integral from pi over 4 to 0 of sine squared of 2x dx. So for this question, we can't immediately integrate sine squared of 2x, so we need to change it to something that we can integrate easier. So in this case, we're going to refer to the formula sheet. We're going to have a look at the identity that 1 minus 2 sine squared of 2x is equal to cos of 4x. And we're going to rearrange this equation to get sine squared x in terms of cos 4x. So in this case, it's just a simple rearranging. So we're going to have cos 4x minus 1 equals to negative 2 sine squared of 2x. And we're going to divide both sides by negative 2. So we have negative 1/2 cos of 4x. Oops, sorry. Negative 4x. And then negative 1 divided by negative 2 is positive 1/2. And now we have a much simpler equation to integrate. So we're just going to replace sine squared 2x with negative 1/2 of cos 4x plus 1/2. So we're going to have integral of pi over 4 to 0 of negative 1/2 cos of 4x plus 1/2 dx. And in this case, we can just integrate cos. Cos integrates to positive sign. So in this case, we're going to have negative 1 over 8. The reason it's negative 1 over 8 is because it's cos 4x. If you differentiate 4x, you're going to get 4. And when you integrate, you're going to divide by the derivative of the inner function, which in this case is 4. So we're going to divide by 4. So negative 1/2 divided by 4 is negative 1/8. And 1/2 just integrates to 1/2 of x. So we have cos of 4. Sine of 4x plus 1/2 of x from pi over 4 to 0. So we're just going to chug in the values pi over 4 and 0 and see what we get. So this will give us negative 1 over 8 sine of pi plus 1/2 of pi over 4 minus 1/8 of 1/8 of sine of 0 plus 1/2 of 0. So the right hand side here, that's just going to go to a 0. Since sine 0 is 0 and 1/2 times 0 is 0. Sine of pi is also 0, so that also goes to 0. So in this case, we're just going to have, I'm going to go to here, so we're going to have 1/2 of pi over 4, and that equals to pi over 8. So that should be your final answer, pi over 8. And this is a pretty standard, should be a pretty standard merit level question. And achieved grades usually come with a correct integration. So if you can get up to -1/8 sine 4x plus 1/2 of x, so this step here, that should be enough for an achieved grade there. All right, let's have a look at question number D. The graph below shows part of the function y equals to 4 over square root of 3x minus 2. We're going to find the value of k such as the shaded region has an area of 8. So in this case, we're going to look at the bounds from x equals to 1 to x equals to k, and we know that the area is equal to 8. So what we do know is that the indefinite integral for 4 over square root of 3x minus 2 dx from k to 1 is equal to 8. And that is equal to the area underneath the graph. So all we need to do is just integrate 4 over square root of 3x minus 2. So we're going to use the substitution here. So we're going to integrate 4 over 3x minus 2 dx. So in this case, we're going to use a substitution. We're going to say that u equals to 3x minus 2. And we're going to say that du over dx is equal to 3. And if we rearrange this, we should get that dx equals to du over 3. And we're going to chuck dx in for dx in the equation and make our substitution. So in this case, we're going to have 4 over square root of u times du over 3. We're going to rewrite this as the integral of 4 over 3 multiplied by u to the power of -1/2 du. And in this case, we can just use the power rule. So you're going to add 1 to the power and divide by the new power. Very simple. So -1/2 plus 1 is +1/2, and you divide by +1/2 is the same as multiplying by 2. So you should get 8 over 3 u to the power of 1/2, and that equals to 8 over 3 multiplied by 3x minus 2 to the power of 1/2. So we're going to replace u by our substitution, 3x minus 2. And we know that this from k to 1 is equal to 8. All right, brilliant. So now we can say that 8 over 3, plugging in k is 3k minus 2 to the power of 1/2 minus 8 over 3. Plugging in 1, so we get 3 times 1 is 3, minus 2 is 1 to the power of 1/2 equals to 8. So we can just simplify this equation further. So 8 over 3, 3k minus 2, 1/2, minus 8 over 3 equals to 8. And now we can say 8 over 3, 3k minus 2 to the power of 1/2 equals to 8 plus 8 over 3, which is 32 over 3. So 3k minus 2 equals to divide both sides by 8 over 3, which equals to 4. And we're going to square both sides. So we have 3k minus 2 equals 16. And if we just do a really quick solving for k here, we just get k equals to 18 over 3. So our answer should be k equals to 18 over 3. That's our final answer. And again, this is a very typical merit level question. So getting up to there should give you a merit grade. In terms of getting an achieved, once again, you should be, if you can integrate your equation properly, that's usually enough for an achieved. So if we're looking, we should be looking at, if we can get up to this step here, that should be a achieved grade there. The graph below shows a function y equals to e to the power of x whole squared and y equals to 3 e to the power of x plus 10. We want to find the exact value of the shaded area. So in this case, to find the shaded area between two curves, we're going to name the top curve, we'll just say g of x, and we say f of x. So the shaded area is just f of x minus g of x dx from b to a. So that's the equation for finding the shaded area between two curves. But in this case, we're going to have to find the area. Alright, so in this case, we're going to have to find out which one is on top and which one's on bottom. And to do this, there's multiple ways you can do this, but I find that a very easy thing to just do. We can just look at the point x equals to 0, so we can just look at this point here. Let's plug in x equals to 0 for both of the curves. So we can say for this curve here, we have y of 0 equals to e to the power of 0 squared, which is 1. And for this one here, we have y of 0 equals to 3 e to the power of 0 plus 10, and that's 13. And clearly we see that for y1, we call the second one y1. So for 3 e to the power of x plus 10 is clearly above e to the power of x whole squared. So we know that this is y equals to 3ex plus 10, and down here is y equals to e to the power of x squared. Alright, so brilliant. So now we can write out our equation for finding the area in between the two graphs. So in this case, we have the area would be between B and A of 3ex plus 10 minus e to the power of x whole squared dx. So in this case, we need to find what B and A are. And in this case, we're going to look at the intersection between the two graphs and as well as the origin point, which is x equals to 0. So we know that A equals to 0 in this case because that's where we're going to be starting, x equals to 0. But we need to find our B value. So this will be our B value, and we need to find this one. So to find this point, we're going to find the intersection, so making the two graphs equal to each other. So 3e to the power of x plus 10 equals to e to the power of x whole squared. So in this case, we're going to have to use a substitution. So we can see this is a quadratic in terms of e to the power of x. So we're going to say let r be equal to e to the power of x, and we're going to solve a quadratic. So 3r plus 10 is equal to r squared. So r squared minus 3r minus 10 equals to 0. This factors pretty nicely. We're going to get r minus 5 and r plus 2 equals to 0. So therefore, r equals to 5, r equals to negative 2. But in terms of r equals to negative 2, that's not a valid solution because e to the power of x strictly greater than 0. So therefore, we cannot have r equals to negative 2. So therefore, we know that r equals to 5 and e to the power of x equals to 5. And we know, taking the log of both sides, we're going to have x equals to ln of 5. And that equals to our b value, which we were trying to find. So in this case, we're going to substitute our b for ln of 5 and a for 0. So we're going to have integral of ln of 5 and 0 of 3 to e to the power of x plus 10 minus e to the power of x whole squared is equal to e to the power of x times e to the power of x. And in this case, we're going to add the powers. So we're going to have e to the power of 2x. We're just going to replace that by e to the power of 2x dx. And that equals to, if we want to integrate, it's pretty easy. So e to the power of x, the integral is just e to the power of x. And the integral of e to the power of 2x is just the derivative of 2x, which is 2. I'm going to divide by 2. So it's going to be negative 1/2 e to the power of 2x. So we're going to have 3e to the power of x plus 10x minus 1/2 of e to the power of 2x ln of 5, 0. And we're going to plug in ln of 5 and 0 into the equation. So we have 3e to the power of ln of 5 plus 10 ln of 5 minus 1/2 e to the power of 2 ln of 5 minus 3e to the power of 0 plus 10 times 0 is just 0 minus 1/2 of e to the power of 0. So let's simplify this a little bit. So in this case, we have e and ln of 5. So the e and ln cancel out. We're going to get 3 times 5. So 3 times 5 plus 10 ln of 5 minus 1/2. In this case, we have 2 ln of 5, but we know that, let me just do a side note. So we have 2 ln of 5. We know that this equals to ln of 5 to the power of 2. So that's our log rule. So this equals to ln of 25. So that equals to ln of 25. So similarly to what we did with 3e to the power of ln of 5, we can rewrite that as 25 minus 3e to the power of 0 is 3, minus 1/2 is 2.5. So minus 2.5. So 3 times 5 is 15, minus 1/2 of 25 is minus 12.5, minus 2.5, that's 0. So that all cancels out. So we're going to be left with 10 ln of 5. And that's the area. And that in decimal form, that is approximately 16.1 units squared. That's approximately. Alright, and this will be an excellence level question, and getting the final answer should be enough for an excellence. In terms of getting in merit grade, I would say it's quite tricky, but in terms of a merit grade, I reckon if you can integrate correctly and find the points of intersection, that could be enough for a merit grade. So I'm not 100% sure, but if I was to grade this question, I'll be giving a merit grade for correct integration and finding ln of 5 and 0 as the two bounding points. That could be enough for a merit. And in achieved, I reckon if you can just integrate correctly, so if you have the formula for the area between two graphs and integrate that correctly, that could be enough for an achieved. So if you just want to integrate correctly, that's just correct integration. All right, let's move on to question 2. So find the integral of e to the power 3x minus square root of x dx. So we're going to rewrite this really quickly as integral of e to the power 3x minus x to the power 1/2 dx. And we're just going to follow our standard integration rules. So 3x derivative is 3, so we're going to divide by 3, so 1/3 e to the power 3x. And for x to the power 1/2, we're going to use the power rule. So 1/2 plus 1 is 3/2, and we're going to divide by 3/2, divide by the new power, which is 3/2, and we're going to get negative 2/3 x to the power 3/2. And don't forget the constant of integration, plus c. And that should be another very simple achieved level question there. So that should be an achieved grade for this question. Alright, let's have a look at B. Find the value of k given that the integral from k to 1 of 2 over square root of x dx is 8. So in this case, we're just going to integrate and then evaluate the indefinite integral, make it equal to 8, and find the value of k. So we're going to rewrite this as k1 2 times x to the power of negative 1/2 dx. And again, we're just going to use the power rule, so plus 1 to the power divided by the new power. So we're going to get 4 square root of x, k to 1, and that equals to 8. So let's substitute in our k and 1. So we have 4 root k minus 4 root 1 equals to 8. So we have 4 root k equals to 8 plus 4, which is 12. So root k equals to 3 and k equals to 9. And that should be another very simple achieved question there. Consider the differential equation dy over dx equals to 1 over 3y squared times x minus 1, and x is greater than 1. So in this case, this is a separable differential equation, so we can separate the variables of y and x on both sides, and we're going to integrate both sides to find an explicit equation for y in terms of x. So in this case, we're going to separate variables. We're going to have 3y squared on one side, and that equals to the integral 1 over x minus 1 dx on the other side. So if we integrate 3y squared with respect to y, we're going to add 1 to the power and divide by the new power, just the power rule there. So that's just y to the power 3 equals to the integral of 1 over x minus 1 with respect to x, and that's just going to be ln of x minus 1, and don't forget the constant of integration plus c. We're given the initial point, so we can use the initial point to find the value of c. So we know that y equals to negative 1 when x equals to 2, so we're going to have negative 1 to the power 3 equals to ln of 2 minus 1 plus c. So negative 1 equals to ln of 1, which is 0, so equals to c. So therefore, we have y cubed equals to ln of x minus 1 minus 1. Perfect. Okay. So now the question wants us to find the values of x given a y value of 1. So we substitute y equals to 1 and we solve for x. So 1 to the power 3 equals to ln of x minus 1 minus 1. 1 cubed is 1, and we move the negative 1 to the other side, which gives us 2. So 2 equals to ln of x minus 1. And we know that e squared equals to x minus 1, and therefore x equals to e squared plus 1. Alright, and that should be a merit level question for the correct answer. With a merit grade being able to find the correct explicit equation in terms of y cubed and x. So we have y cubed equals ln of x minus 1 minus 1. That should be enough to get you an achieved grade there. Question number D. An object's acceleration can be modeled by equation a of t equals to 0.9 times e to the power of 0.3 t. A is the acceleration and t is the time in seconds. The object has a velocity of 10 meters per second after 2 seconds. So how far did the object travel during the fifth second of its motion? So in this case, we need to find the we have the equation for acceleration. We need to integrate to find the velocity and integrate it again to find the distance. So we know that v of t is equal to the integral of a of t dt, which is equal to the integral of 0.9 times e to the power of 0.3 t dt. And that equals to, we're just going to use our standard integration rules for e. So in this case, the derivative of 0.3 t is 0.3. And we divide by 0.3, so 0.9 divided by 0.3 is 3. So the coefficient is 3 multiplied by e to the power of 0.3 t plus the constant of integration plus c. To find our c value, we're going to be using our initial conditions. So the velocity is 10 meters per second after 2 seconds. So we can say that 10 is equal to 3e to the power of 0.6 plus c. So therefore c equals to 10 minus 3 e to the power of 0.6. And you can actually just rewrite this in a decimal form, or you can just choose to leave it as 10 minus 3 e to the power of 0.6. I don't think NCA is too fussy on exactly what you do here, but I'm just going to leave it as 10 minus 3 e to the power of 0.6 for now. So we need to find how far the object traveled during the 5th second of its motion. So that's the same as saying the definite integral of between 5 and 4, which is the 5th second of its motion. And we're going to integrate the velocity function to find the distance function. So I'm going to say v of t dt equals to distance in 5th. Okay. So in this case, we're going to say that this is equal to 3e to the power of 0.3 t plus 10 minus 3e to the power of 0.6 dt between 5 and 4. And we're just going to integrate again using the same rule for e. We're going to get 3 divided by 0.3, which is 10. So 10e to the power of 0.3 t plus 10 minus 3e to the power of 0.6 multiplied by t. Alright, so let's just evaluate this indefinite integral. So just plugging in the numbers. Just be careful to not make any mistakes in your computation here. So we have 10e to the power of 0.3 times 5 is 1.5 plus 10 minus 3e to the power of 0.6 times of 5 minus 10e to the power of 1.2 plus 10 minus 3e to the power of 0.6 times of 4. And if you evaluate this this expression, and you can either leave it in absolute form or you can leave it in decimal form. But if you want to get a decimal form, you should get approximately 16.15 meters. And that should be a merit level question to get the final distance traveled in the 5th second. And if you want to get an achieved level grade, it's usually if you can find the velocity function and find the value of c. And I think that would by itself that should be enough for an achieved grade there. Let's have a look at question number E. A cylindrical tank of height 150 centimeters is originally full of oil. The tank starts to leak out of a hole in its side. The height h in centimeters of the oil left in the tank after it has been leaking for t minutes can be modeled by a differential equation. So that's dh over dt equals to negative 1/4 of the square root of h minus 6 cubed. Find how long it takes for the oil in the tank to be 15 centimeters above the bottom of the tank. So in this case, we also have similarly to, I think, the question number C, we have another separable differential equation. So we're going to separate the h on one side and then the t's on another side, integrate on both sides to find a explicit formula for h in terms of t. So in this case, we can rewrite our equation dh over dt. We can rewrite it as 1/4 of h minus 6 to the power of 3 over 2. And we're going to separate our variables. So we're going to have integral of 1 over h minus 6, 3 over 2. dh equals to integral of negative 1/4 dt. So for this question, we can either immediately, for integration of the left-hand side, we can use a substitution of u equals to h minus 6. But notice that if we differentiate both sides, we get du equals dx. So it's just 1. So we actually don't really need to worry about having a substitution here because the derivative is just 1 anyway. So in this case, we can just treat this as any other power rule question. So we can have integral of h minus 6 to the power of negative 3 over 2 dh equals to negative 1 quarter t plus c. So we're going to add 1 to the power and divide by the new power. So negative 3 over 2 plus 1 is negative 1/2, and 1 divided by negative 1/2 is negative 2. So in this case, we're going to get negative 2 times h minus 6 to the power of negative 1/2, and that equals to negative 1 quarter t plus c. So let's rewrite this in a bit more neat way. So we have negative 2 divided by the square root of h minus 6. That equals to negative 1 quarter t plus c. So now we want to find the c value, which will be given to us by the initial conditions. So the initial conditions is that the height is 150 centimeters when t is 0. So t equals to 0, h equals to 150. So negative 2 divided by square root of 144 equals to negative 1 quarter times 0 plus c. So therefore, c equals to negative 2 over 12, which equals to negative 1 over 6. So in this case, we have negative 2 over square root of h minus 6, and that equals to negative 1 quarter t minus 1/6. Alright, so now we're going to plug in, the height equals to 15 centimeters and solve over time. Let me just check, 15 centimeters above the bottom of the tank. Yeah, so we're going to plug in our height is 15. So we have negative 2 over square root of 9. That equals to negative 1 quarter t minus 1/6. So negative 2 over square root of 9 is negative 2 over 3 plus 1 over 6 equals to negative 1 quarter t. So therefore, we'll have negative 1/2 equals to negative 1 quarter t. And therefore, t equals to 2 minutes. So 2 minutes should be your final answer for this question, and that should be an excellent level grade if you can find 2 minutes as your final answer. In terms of getting a merit level grade, I believe if you can integrate correctly and find the c value, that should be giving you a merit grade. So getting up to this step here, that should be a merit. And an achieved grade should be able to separate, if you can separate the variables, separating the variables and integrating successfully on both sides should be a achieved grade. So if you can get up to this step here, that should be more than enough for an achieved level grade. Alright, so let's look at question number 3 now. So find the integral of 2x plus 5 to the power of 3 dx. So in this case, we have integral of 2x plus 5 to the power of 3 dx. So in this case, if we look at the inner function is 2x plus 5, we can either use a substitution here. So we can say like 2x plus 5 equals to u. And you get du over dx equals to 2. And if we can plug that one in, we'll get, we can rewrite dx equals to du over 2. So you get 1/2 of u 3 du. And that equals to 1/8 of u4 plus c, which equals to 1/8 of 2x plus 5 to the power of 4 plus c. However, you can also note that we can use substitution, so 2x plus 5 equals to u, or you can notice that the derivative of the inner function is 2, and when you differentiate something, so let's say we want to differentiate 2x plus 5 to the power of 3, you will move the power down, so you get 3 times of 2x plus 5 to the power of 2, so the power minus 1, and you're going to be multiplying by the derivative of the inner function, which is 2. So if you're going the other way around, you can note that instead of multiplying by the inner function derivative, you can simply divide by the inner function derivative. So in this case, you can just divide by 2. So in this case, you can just follow a very simple standard power rule. So in this case, we can say that, so if we look, so method 2, we can use our power rule instead. So we can say that, so 3 plus 1 is 4, and we're going to divide by the new power, which is 4. So we have 1 quarter times 2x plus 5 to the power of 4. And we're going to divide by the derivative of the inner function. And the derivative of the inner function is 2. So we're going to divide by 2, which is the same as multiplying by 1/2. And that is 1 over 8, 2x plus 5 to the power of 4 plus c. And that is exactly the same answer that we got with our substitution. But I find that method 2, if you're able to get used to using method 2, I find it's a lot faster than using a substitution. So if you find that time is an issue during the exam, I recommend that you get familiar with these like little tricks that will really greatly reduce the amount of time you spend on some of these questions. So this is just a standard achieved question though. Use the values given in the table below to find an approximation to the integral of 2 from 2 to 0 of f of x dx using the trapezium rule. So the trapezium rule in this case is if we draw trapeziums for all our sections, the sections on both ends are only going to be counted once, but every section in the middle is going to be counted twice because of the overlaps. So in this case, we're going to sum 2 times of everything here, and so it's just be 2 times of everything here, 1 times and 1 times there. We also want to find the height value. So in this case, the height of trapezium is equal to b minus a over n, and that is equal to 2 minus 0 over n. And in this case, n is we have n equals 0, 1, 2, 3, 4, 5, which equals to n. So n equals to 5. So height is equal to 2 over 5. So our integral of 2 to 0 of f of x dx equals to 1/2 times 2 over 5 multiplied by 3.6 plus 3.2 plus 2 times of everything in the middle, which is 4.2 plus 4.8 plus 5.4 plus 4.5. And if you're wondering how I got to this step, you can double check the formula for the trapezium rule on the formula sheet. And in terms of this answer, if you simplify it, you should get, the answer should be 8.92. And that should be another achieved question there. Question number C, we're going to be finding the indefinite integral of 8 to 5 of 4x minus 5 divided by x minus 3. So for this question, it's pretty tricky to just integrate this straight away. Like, what do you do? Because you have both x on the numerator and the denominator. But notice that they're both of the same degree of 1, polynomials of degree 1. So we can just do a polynomial division of 4x minus 5 and x minus 3 to simplify our equation. So we have 4x minus 5 and x minus 3. If we put a 4 here, we're going to get 4x minus 12. And don't forget it's minus, so it's negative 5 minus 12, so it's positive 7. So in this case, we can rewrite this as 8, 5 of 4. And then the remainder is 7, so we have 7 over x minus 3 dx. And now this looks very familiar, so we can just get 4x plus 7 ln of x minus 3 from 8 to 5. So what we need to do now is just plug in the values in 8 and 5 and be careful to not make any computational mistakes here. So 8 times 4 is 32, plus 7 ln of 8 minus 3 is 5, minus 4 times 5, which is 20, and minus 7 ln of 2. Alright, and you can either leave your answer, as 12 plus 7 ln of 5 minus 7 ln of 2. That's fine, but you can also just get roughly give a decimal answer here, which is 18.414. And that should be a merit level grade. And typically for these questions, a correct answer is merit and a correct integration is achieved. So correct integration right there should be achieved there. Question number D. The graph below shows part of the curve y equals to x plus cosine of x and the line y equals to x. We want to find the shaded area. So remember back on part 1e, we also had the same type of question to find the shaded area between two graphs. So in this case, we're just going to be using the top graph minus the bottom graph, and we're going to integrate from b to a, which is the bounds of the curve. Alright, so in this case, it's pretty easy to tell which graph is which because clearly the straight line here is y equals to x and the curved line here would be y equals to x plus cosine of x. So if we just write out our equation for the area, we can get area equals to integral of b to a of x plus cos of x minus x dx, which is just cos of x dx. So now the harder part is finding the points of intersection here and here. So remember in part E we did the same thing, so we're going to just make the two graphs equal to each other. So cos x equals to x. It's gone. So cos x equals to 0. To solve cos x equals to 0, I always find it helpful when you're working with the cosines and the sines. You can always just use a unit circle, and in this case a cosine would be the horizontal component, so you're going to find when that's equal to 0. So we're going to have this point here, that point there, this point there, and in this case here this will be pi over 2 and this will be negative pi over 2. So x equals to pi over 2 and x equals negative pi over 2. And clearly over here, x is negative pi over 2, and here x equals pi over 2 there. So let's substitute that for our b and a bounds. So we have a equals to pi over 2 and negative pi over 2 of cosine of x dx, and that is sine of x of pi over 2, negative pi over 2, and that is equal to sine pi over 2 minus sine of negative pi over 2. And in this case, you can just chug it into your calculator. So sine of pi over 2 is 1. Sine of negative pi over 2 is negative 1. So we get 1 minus of negative 1, which is 2 units squared. And that should be another merit level question. Achieved grade, that's a tricky one. Achieved, I guess if you can integrate correctly, but this is a pretty simple integral because you just have cosine of x going to sine of x. So I'm not too sure exactly how they're going to grade this question, but you might be able to get an achieved grade if you can find just the correct formula for the area between two graphs and then the integral. So that's a big speculation there. So that's a big speculation. Okay, just a heads up for that one. Alright, and last question. The graph below shows part of the curve given by the equation y equals to 2 on x. Points P and Q lie on the curve with x coordinates k and 3k respectively. K is greater than 0. Point R is such that PR is parallel to the x-axis and QR is parallel to the y-axis. The shaded area can be written in the form a plus b ln c. A, b, and c are integers. So for this question, it's very important to just break down the question into the components. So what do we have here? We have a rectangle, and we want to find a component of the rectangle. So we're going to want to find this area here. You notice that this part of the rectangle here, that is simply so we can just say that the red area is equal to the area underneath the curve y equals 2 over x between 3k and k. So that's just... So now, since we know that that area is just the area underneath the graph of 2 on x from 3k to k, all we need to do now is just find the area of the rectangle. So we want to find rectangle area. And our answer, so answer is equal to question mark minus the red area. So that's us just breaking down the question of what we need to find out. So let's just work out the area of the rectangle first. So let's just write down the coordinates of P, R, and Q. So the coordinate of P is equal to k, comma 2 on k. The reason it's 2 on k is because the point P lie on the curve, and if x equals to k, then y equals to 2 on k. So that's how we know that point P is k, comma 2 over k. For Q, we have a similar logic, so it's going to be 3k, 2 on 3k. And in terms of point R is the same y value as P, but it is the x value of 3k. So R is just 3k. K on 2 on k, sorry. And the area of the rectangle equals to base times height. And the base is equal to 3k minus k multiplied by the height. And you notice that the height is just this height here, which is, since this is 0 and this is 2 on k, that is just the distance of 2 on k. Oops. So that would be 2 on k. So that equals to 2k times 2 on k, and that's 4. So the area of the rectangle is 4 units squared. And notice that it doesn't actually depend on k. So for any value of k, if we have a setup of the rectangle in this position of between k and 3k, the area will be 4. That's just for all cases. Perfect. So now we know the area of the rectangle. That's one thing done. So that's great. So that's done now. And now we want to find the area underneath the graph between 3k and k. All right, so let's go and do that. Integral of 2 over x is 2 ln of x. And we just chuck in our values for k. So we have ln of 3k minus 2 ln of k. So remember, we also had a similar situation before. We had like 2 ln of 5 that equals to ln 25. We're going to use the same technique here. So we're going to say that 2 ln of 3k is equal to ln of 3k to the power of 2 minus ln of k to the power of 2. And this will give us ln of 9k squared minus ln of k squared. And remember that if you have like log of the same base, so just log base, just log base of a minus log of b, that is equal to log of a on b. That is another log rule. And remember, these log rules are really important. So as you can see here, just in this exam alone, we're using like a lot of these log rules. So please make sure you're really familiar with these log rules before you go into your exam, because I can almost guarantee you that you will be working with some of these rules. If you're not familiar with them, like it's not really clear what you do with 2 ln of 3k minus 2 ln of k. It's pretty hard to really do anything with it unless you know your log rules. So in this case, we're going to have ln of 9k squared over k squared. That is just ln of 9. Okay, great. So now we have the area of the rectangle. The area of the rectangle is 4, and the area of the red area is ln of 9. So we can see that the shaded area is equal to 4 minus ln of 9. And we are done. So in this case, we can see that a equals to 4, b equals to -1, c equals to 9. Note that you can also write ln of 9. Don't forget, you can also write that as 2 ln of 3. That's the same thing. So you can also have the same answer, which is a equals to 4, b equals to -2, and c equals to 3. So both of these are okay. All right, and that should be this question done. And notice that even though we have like k and 3k, that the final answer didn't really depend on k. And I mean, like one hint you can take from the question is it says find the values of a, b, and c. If it did depend on k, it would say find the values of a, b, and c in terms of k. But since it didn't say in terms of k, I think you can be relatively, or like you can start thinking that possibly that the final answer is not really dependent on k. And that is in fact what we found in this question. We found that the shaded area was not actually dependent on the value of k at all. It just doesn't matter. So in terms of grading for this question, if you can find the final values of the a, b, and c, that should be an excellent grade. In terms of getting an achieved grade, I can say maybe you can find the area of the rectangle, maybe that could be an achieved, or you can find the area underneath the graph, so the red area. And if you can find both the areas, then that could be a merit grade. So if you can get like both these ones, that could be a merit. If you can find like one of these, maybe like either 4 or ln of 9, either or, that might be an achieved grade there. Alright, so thank you for watching this video for the 2022 Level 3 Integration exam. Hope you enjoyed, and if you have any questions, leave it down in the comments below, and I hope to see you all in the next one.